This will be a tutorial reviewing vectors. Some of this you've seen before in your math classes, Algebra 2 and Trig, for example, but we'll kind of put it all together. So what I want to do is just talk about how do we break down vectors into components, and then how do we use that process to add vectors. So a quick reminder, a vector is any quantity with a direction. When you live in a one-dimensional world, if you have a vector that goes this way, say that's vector A, and it is 10 units long, and then you have another vector, and it goes like this, and that is 7 units long, then the result of those two vectors, so let's call this A, and this is vector B, and we use these symbols to indicate that those are vectors. If I said, what is A plus B? What is the result of adding A plus B? Well, that's pretty easy. If they're in the same direction, that's just simply a vector that is 17 units long. So it starts here and it ends there. So we would say the result, A plus B, is a vector like that. Okay? And sometimes we call that the resulting vector, R. Okay? So that's fairly straightforward. Also, if you have a vector that is 10 units long and another vector B, which maybe looks like this, and it's 7 units long, then in this case, A plus B, the vector A plus the vector B, is the vector that starts at the beginning of the first one and ends at the end of the last one. So that simply looks like this. So if that's 10 units long and that's 7 units long, the result of A plus B in this case would be a vector which is 3 units long. Okay? So life is pretty easy when you live in one dimension. The problem is most of our world is a multi-dimensional world, so we have to worry about 2 and 3 dimensions. So we're just going to take a look at what happens. Now, before we can add vectors in 3 dimensions, so let me kind of give you an example problem. So suppose we have a vector, and the first vector is 15 units long at 60 degrees. So that kind of looks like that. And let's say that's 15 units long. So that's vector A. And to that we want add another vector that is 12 units long, and that vector is at an angle of perhaps 10 degrees. So this angle right here is 60 degrees. We always measure the angles from the positive x direction, so that's the angle there. And then this vector here is at a much more shallow angle. This angle right in here is only 10 degrees, so the second vector. So if that is vector B, then asking what is A plus B is really a vector which starts here at the beginning of the first one and it ends here. So this is the resulting vector. It's the result. So you could think of it like this. If you want to hike and let's see, A was 15 units. So 15 was A and B was 12 units. So if you went on a hike and you hiked at 60 degrees, 15 miles, and then you hiked at 10 degrees, a distance of 12 miles, you would end up here. And so the result is this vector that starts here and ends there. And we've got to find that result. Okay, that's the goal of today's lesson. So in order to do that, there's a lot of ways you could do that. You could use all kinds of fancy trig. You could use laws of sines. You could use laws of cosines. But the easiest one for most students, and the one that is probably the easiest to understand, is to break these down into components. So let's just do a quick review of how to find the components of a vector, and then we're going to come back to this problem and solve it. Okay? So to find the components of a vector, this is what we are going to do. If I have a vector, and let's say it is 15 units long, and it's at 60 degrees. So here's my vector. I will call it A. The length of A is 15 units. And it is at an angle of 60 degrees. What I want to know is, how far does this vector go in this direction? We can call that the x component of the vector because it's horizontal. And how far does the vector go in this direction? We call that the vertical component. So if this is the vector A, we sometimes call this the x component of A, and we call this the y component of A, right? Because x is our traditional horizontal variable. And I want to know what is the x and the y component of A, all right? So a quick review of trig. You may or may not remember that the sine of an angle is always equal to the length of the opposite side divided by the length of the hypotenuse. So sine is opposite over hypotenuse. In this case, what that means is that the sine of the angle, the sine of 60 degrees, is equal to the opposite side, which is the vertical component of the vector, divided by the hypotenuse, which is just a. So if I want to know what is the vertical component of the vector, I'm just going to solve this for ay. I can multiply both sides by a. So that tells us that the y component of the vector is simply a times the sine of the angle, 60 degrees. Okay? And for this problem, that means that a in the y direction is equal to the length of the vector, the hypotenuse, which is 15 units, times the sine of 60 degrees. And if you get your calculator, and you should, hit pause, put this in your calculator. Take 15 times the sine of 60 degrees. Make sure you're in degrees mode on your calculator, and you should get 12.99. 12.99 units. Okay? Go ahead and check and make sure that works for you. Okay? The other trig function that interests us is cosine. So the cosine of an angle is always equal to the adjacent side divided by the hypotenuse. And so for this, that means that the cosine of the angle, the cosine of 60 degrees, equals the adjacent side, which is a sub x, divided by the hypotenuse, which is a. So if you want to find a sub x, you can simply take a times the cosine of the angle. In this case, that means 15 times the cosine of 60 degrees. Put that in your calculator and make sure you get the same answer I do. You've got to be in degrees mode on your calculator. And you should get 7.5 units. So what that means is that if you go on a hike at 60 degrees and you go 15 miles, for example, the horizontal component, how far you went east, turns out to be 7.5. So this is 7.5 miles. And the vertical component turns out to be 12.99 miles. Okay? And you can check that by using Pythagoras' theorem. You can take 7.5 squared plus 12.99 squared and take the square root, and that gives you back your 15. Okay? So the upshot of that is when you have a vector, so here's a general vector. Its length is v, and the angle is theta. The x component of the vector is always given by v times the cosine of the angle, and the y component of the vector is given by v times the sine of the angle. Okay? So to find the horizontal component of this vector, which means how far it goes horizontally, this is the horizontal component. You take v, the vector, times the cosine of the angle. To find the vertical component, how far it goes in this direction, you take v times the sine of the angle. So this is the velocity in the, v in the x, and this is the vector in the y direction. Okay, so we are going to use that to solve the problem that we're interested in. Okay? All right, so let's go back to what we've got. So here's the problem we want to solve. I've got two vectors, and I'm going to add them. Vector A is 15 miles at 60 degrees, and then vector B is 12 miles at 10 degrees. So the easiest way to do this is to break it into components. Okay? So I'm going to make a little table of the components. I've got vector A and vector B, and what I want to do is I want to find the components of those vectors, and I want to find the components in the x direction and the y direction. Okay? So, using what we just reviewed, if you want to find the x component of vector A, I've got to take vector A, which is 15 miles, and I've got to multiply it by the cosine. So this is going to be times the cosine of the angle, which is 60 degrees. Okay? To find the x component of vector b, I'm going to take the length of vector b, which is 12 miles, and I'm going to multiply it by the cosine of the angle of vector b, which is 10 degrees. In the y direction, this is going to be 15 miles times the sine of 60 degrees, and this is going to be 12 miles times the sine of 10 degrees. Okay? So that's how you would find the components. So when I actually worked that out, and I probably should have left some more space here to figure out what these were. When you actually work that out, what you get is A and B. The components look like this. So you can grab your calculator and you can check my work here and make sure. But the x component of vector A should be 7.50 miles, and the y component should be 12.99 miles. And we did that one just previously, so that one's not too hard. Here, when you take 12 times the cosine of 10 degrees, you get 11.82 miles. And here you take 12 times the sine of 10 degrees, and you get 2.08. And again, make sure your calculator's in degrees mode. Okay, so here's what we did. We found the x component of vector A, and we found the y component of vector A, and then we found the x component of vector B, so this is b and the x, and we found the y component of vector B, that's b and the y. And so we now want to look at this overall vector. Okay, so the resulting vector is a vector which starts right here and it ends up over here. So this is the resulting vector. It starts at the beginning of the first one and it ends up at the tail of the last one. So this is the vector we're interested in. And how far it goes horizontally is the horizontal component of A. That's how far it goes horizontally here. And then the horizontal component of B. We add those two together and we will get the horizontal component of the result. So if I want to know what is the resulting vector, if I take how far A goes in the x direction plus how far B goes in the x direction, that tells me how far this resulting vector goes in the x direction. So I'm just going to add these two, and I get 19.32 when I do that. So my resulting vector goes 19.32 meters, or miles, excuse me, in the horizontal direction. And in the y direction, I simply add these two, and I get 15.07. 15.07 miles. So here's what we end up with when we're all done. We end up with a resulting vector that starts here, and it ends up somewhere over here. So this is my resulting vector. What I know is how far it goes horizontally. I know the result in the x direction, and I know how far it goes in the y direction. That's these two values. So this is the resulting vector in the y direction. So if I want to know how long is this vector and what angle it is, I'm going to use these two components. These are the components of the result. The result is 19.2 horizontally and 15.07 vertically. So if I have the x and the y components to find the hypotenuse, since this is a right angle, I can just use Pythagoras' theorem. The resulting vector is going to be the x component squared plus the y component squared, and then the square root of all that. So that's just using Pythagoras' theorem. So if I take 19.32 squared plus 15.07 squared, and then take the square root, I get the length of the resulting vector. In this case, 24.5. So 24.5 miles is the resulting vector's length. And we usually write length as the magnitude with that symbol. It's like the absolute value. It just tells you how long it is, not what direction it is. Now, to find the angle here, we have to do a little bit of trig. The tangent of an angle is the opposite side, which is ry, divided by the adjacent side, which is rx, the components in the x and the y direction. So that tells us, I'm going to move this a little bit, that if we want to know the angle, it is simply going to be the arctangent of the y component divided by the x component. Okay? So on your calculator, sometimes this looks like this. It's the arctangent. And we're going to put in the y component, which is 15.07, divided by the x component, which is 19.32. And when you plug that in your calculator, if your calculator is in degrees mode, you will get an answer of about 37.97. 37.97, and we're in degrees mode, so we get degrees. So here's the upshot of the whole thing. The resulting vector is 24.5 miles long at an angle of 37.97 degrees. That is our answer. That is what we get when we add the two vectors together. Okay? So that's what you're going to do. Make a sketch, draw each of the two vectors, find their components, use the components to find the components of the result, and then reassemble the resulting vector, once you know its x and y components, reassemble it to find its length and its direction, and then you'll have the answer. Okay?